Hello friends, welcome to our channel. Let's look at today's daily challenge problem. Minimum equal sum of two arrays after replacing zeros. So in this video, I guess the coding is less crucial, but the reasoning is more important. So here we are going to use mathematical inequality and some simple reasoning. So here we are given two arrays, nums1 and nums2, consisting of positive integers. I would say this is not accurate. It should be non-negative integers because you have zeros, right? So you have to replace all the zeros in both arrays with strictly positive integers such that sum of elements of both arrays become equal. So return the minimum equal sum you can obtain, or -1 if it's impossible. So I'm going to analyze the two examples and then write the code. Hopefully from these two examples, you can get a flavor of the reasoning. So I would say the two examples are not fully representative, but in our code, we'll demonstrate all possibilities. So in the first example, so if you count the sum, actually the sum is 6, right? So S1 is 6. And there are two zeros. I'm going to call it C1 is 2, right? So S2 is 11, right? So they have 1 zeros, right? So then what we want to do is S1 plus C1 equals S2 plus C2, right? So here S2 actually is larger than S1. So we actually can do this. C1 equals S2 minus S1 plus C2. That is C1 we want this. S2 minus S1 is 5 plus C2. But each C2, because this is the count, so each number is replaced at minimum should be 1. So therefore we should have this one is we should this if once, because this you can assign arbitrary positive integer. So for C1, so the left side is actually at most at least 1. Well, for the right side will be at least greater than or equal to because C2's count is 1, at least 6, right? So we need to make them 6. In other words, we assign the sum of the two zeros in the nums1 to be 6, right? And then we assign the C2 to be 1. So we have 2 plus 1, 6, right? So if we set C2 to be 1 and C1 to be the summation of the two zeros to be 6, so we get the total sum will be 12. So this is the return, is 12. So this is example 1. So well, for example 2, let's also use this pattern. So here S1 is 4. And we have two zeros, and S2 is 5. So here, this is 4, right? So we have C2 is 0. So here C1 is 2. So what we want is 4 plus C1 equals 5 plus, because you have nothing 0, so you need to have this. So, but here C1 has two counts, right? So the left side is at least. Left side is at left-hand side is at least, so 4 plus 2. So, but the right-hand side is 5. So therefore, it's impossible. We are going to return -1, right? In other words, we need to consider the sum relation and also the count C1 and C2. So this will be our overall thought process. So next, I'm going to analyze on this. I guess for this problem, the coding and the run-through are almost identical. So I'm going to directly write the code. So we have S1, S2 equals sum of nums1, sum of nums2, right? So let's also count the zeros, C1 and C2, right? So that is nums1 count 0 and nums2 count 0. So notice that it's possible C1 or C2 is 0, right? There's no 0 element. So now let's discuss different situations. First, if S1 equals S2, let's consider this one. So if C1 is 0, in other words, the left-hand side just have a plain sum, that is S1, no zeros. And then let's look at the right side. If C2 is also 0, right, then the two sums are already equal, but we do not have zeros for sure. In this case, we just need to return either S1 or S2. So we return S1 here. Else, if C2 is not 0, then because C2, as long as you have have 0 element, you need to replace it by strictly positive integer. Therefore, these two cannot be the same. So we're going to return -1. So that's the for sure. This is for C1 equals 0. Otherwise, if C1 is not 0, symmetrically, if C2 is 0, so we are going to return -1. Otherwise, what we do? Both C1 and C2 are non-zero, right? So here we have some scenario like this: S1 plus 13 non-zero element, so at least a C1, right? We want this to be equal. So here you should interpret this C1 and C2 are variables, two variables, at most the count of zeros. So we need to make this the larger one, right? So we just need to return the larger of C1 or C2. Then we need to return S1 plus the larger, or S2, because S1 and S2 are the same. So we need to return S1 plus max C1 and C2. So this is the one case when S1 equals S2. This is rather simple. Otherwise, S1, let's consider this case. S1 is greater than S2. So if S1 is greater than S2, we have such a scenario. We have S1 minus S2. This is the positive thing, plus two variables, C1 and C2. We want to see if we arrange C1 and C2 to make it equal. So in this case, first let's consider if C2 is not 0, right? So if C2 is not 0, then let's consider this one. If so we need to distinguish two cases. If C1 is 0, right? So in this case, if C1 is 0, the left-hand side is a fixed number, that is S1 minus S2. But C2, we have this number of freedoms, right? So the right-hand side is at least C2. So what we want to have is that if S1 minus S2 is greater than or equal to the count of non-zero elements, and then what do we do? So we can make the summation, so the degree of freedoms on these numbers to be with a sum S1 minus S2, right? So this way we just need to return S1 minus S2. So this you can regard it as C2, right? So then you plus S2, C2 plus S2, the C1 plus S1, right? So this actually is S1, right? This is what you need to return. Otherwise, so C1 is 0, and then this sum is less than the count of 0 elements in the second list. So it's impossible to make it the same. So we're going to return -1. So this is for C2 equals 0, right? So here C1 is 0. If C1 is not 0, right? So then we have lots of freedoms. So to, we consider which one in this left side and the right side is larger. So we pick the larger. We make the two sets equal to the larger one. You need to think C1 and C2 are the parameters now, not the exact count. So what we want to return is that, so we want to return the max of S1 minus S2 plus C1 and that of C2. So we want to make C2 or this sum equals the larger of these two. So, and then we should add S2, right? So this is the one thing. Otherwise, so if C2 is 0, right? Because if this guy is 0, right? So this is positive. So it's impossible and the two sides are equal. So we're going to return negative 1. So this is this else if condition. Then in the else, so we should have S1 is less than S2. Then we can do it by symmetry, right? So here if C1 does not equal to 0. So here, because by symmetry, I'm just directly writing the code. So if C1 of 0 to 0, if C2 equals 0, then if S2 minus S1 is greater than or equal to C1, so in this case, I'm going to return S2. Otherwise, so I'm going to return negative 1. So this is the one. Another case is that we're going to return S1 plus the max of C1 and S2 minus S1 plus C2. So this is one. Otherwise, I'm going to return negative 1. The equation you are going to analyze is this. So C1 equals S2 minus S1 plus C2. So this corresponding to else if. This corresponds to the else block, right? So I guess with that said, that's the full code. So I would say this is more mathematical reasoning, not coding. So as long as you know how to write if else or if else if else. Let me first run it. Yeah, it passes the 2 test cases. So now let's look at the generic case. Yeah, it passes all the cases. So I guess that's basically about it for this problem. As for, we can maybe do a temp complexity analysis. So here we get a sum. So, and also this count zeros. So together this is the O of m plus n, where m is the length of nums 1, n is the last length of nums 2. So well, for those, so it's just just O1 operations. So overall it will be O n plus m, the length of the 2 lists. So with that said, I guess that's it for the current video. Thank you for watching.